go. I think that's so funny. We're going to go over homework because I'm guessing people would like to do that. We're going to talk a little bit about what the quiz is going to look like tomorrow. Just a reminder, we do have a quiz tomorrow, homework quiz. We're going to do a little bit of ranking task stuff. I know you're excited, right? And then we're going to do a little activity, and then if we have time, we'll do one more velocity problem. So we've got things to do. We'll get through at least, I don't know, the first 3 or 4 of those, and then we'll kind of see where we're at. The only homework you have for tomorrow is just to get ready for the quiz. So you don't have any extra, like, book problem stuff. Does that seem reasonable? Okay. So if you would like to go get a textbook, I would encourage you to. You can just get one per group. That's totally fine. You don't have to get one per person. That seems a little extreme. Questions on 7, 9, and or 11. Which ones do you want to go through? Yes, ma'am.
Yeah, I don't understand 9 at all.
9 at all. Do you want to know why? It's because the picture is dumb. But I will talk you through it. So get out a book so you can see a book. Okay? So come on, stinker. You said 9. All right, so let's take a look at 9. Oh, it's frozen. You can't see that. There you go. So question 9 says, everybody with me here? We're on page 73. So again, friendly reminder, if you didn't do the homework, this is a good time to write things down. If you did do the homework, this is a good time to double check things, and otherwise just be quiet. Thank you. All right. So 2 cars are traveling on a desert road as shown below. So the problem with the picture below is that there should not be a break because the break in the picture makes it confusing. So those little, what are those called? The telephone poles are spaced out evenly. Okay. After 5 seconds, they are side by side and by the next telephone pole. The distance between the poles is 70 meters. Identify the following quantities. So let's take a look here. I'm going to draw this picture as best I can. So I'm going to draw my road. And then I'm going to draw some telephone poles. So there's one here, and then there's one here, and then there's one here, and we're going to pretend that those are all actually evenly spaced. And what did they say? It's 70 meters in between each one? Okay. And so they've got car B at the beginning and car A at the beginning. And then after some time, so that's why they have a break in the picture, is the like after some time part. I know, I totally agree. So I used to teach from like the, I don't know, edition before this book, and it's the same picture. I'm like, why did you not fix this? Because this is like one of those things that you should fix in a new edition. So they didn't do that, but I'll get you through it. Does this make sense? And so here's car A again. So this is like the after story. Does that make sense? Okay. So what else do we know? There's something else. After 5 seconds. So 5 seconds has passed in each of these times. So the displacement of car A after 5 seconds. How far has car A traveled?
70 meters.
70 meters. If my stylus would work, that would be fantastic. Come on, thing. No, it's not going to, no. There we go. 70 meters. B, the displacement of car B after 5 seconds, 5 seconds, right? How far did it go? Boom. Part C, the average velocity. So average velocity is displacement over time. So it went 70 meters in 5 seconds. Are you with me there? 70 divided by 5 is 14
meters per second.
Okay, boom. Seriously, this is ridiculous. Holy cow. It's hard to teach when you don't have a stylus that works. Please hold. Oh my gosh. Wow, it's like totally taking over. 14. This isn't going to be efficient. There you go. And then B, how do you do B? B says, what is the average velocity of car B?
Oh, you mean
Or C, D, sorry, my bad.
one.
About car B.
145.
Yeah. So you're just going to do 140 meters divided by 5 seconds, and that gives you 28. Does that make more sense?
A lot.
Awesome. Yeah. Yeah. That picture, I just like, I kind of want to just give you guys all little colored pencils and just like color it in right now, but I feel like that would be a little bit bad. All right. Questions about 7 or 11 that you want to go over?
Can you do 11, please?
Sure thing. Yeah. Let's do it. Has everybody got that? Number 9. Come on, little thing. This is going to be a long afternoon if this doesn't work. All right, number 11. A runner A is initially 6 kilometers west of a flagpole and is running with a constant velocity of 9 kilometers per hour due east. Okay, I'm going to write that down. So I'm going to write out my givens, but I'm going to do a list of givens for runner A. So we know that the position, his initial position, I'm going to write this as 6.0 kilometers west of a flagpole. I'm just going to write that down for now. I'm not sure where this is going. All right. And is running with a constant velocity of 9 kilometers per hour. Okay. Due east. Runner B, this is an interesting question. Is initially 5 kilometers east of the flagpole. And what does it say? Is running with a constant velocity of 8 kilometers per hour west. This is a fun problem. I like this one. All right. What will the distance of the 2 runners from the flagpole be when their paths cross? I would draw a picture too. That's exactly what I was going to do. Sometimes, especially when you have problems with 2 objects, if you don't know what to do next, let's just see what's going on. Okay, so let's draw this. So we're going to draw a flagpole. So here's my flagpole. Should we even put a flag on it? Would that be nice? A little green flag waving in the wind. All right. So runner A is west of the flagpole, 6 kilometers. So they're here, running this way, right? Running to the east. That's A. And runner B is east, a little bit closer, east of the flagpole, running this way. And let's mark their distances as well. So this is 6 kilometers. And this is 5 kilometers. 5.0 kilometers. The question says, where are they going to meet? It's a good question. What are we going to do? This is a thinker question, isn't it? We know their speeds. That's true. What else do we know? Or how would we do it? If you figured it out, how did you do it? Go ahead.
So you know the distance they need to get to the flag, and we know their speeds.
Mhm.
Trying to solve for time.
Okay. Are they both going to get to the flag at the same time? Not necessarily. Not necessarily. Because, what's that? What do you mean? Say that again, because I'm not quite sure what I understand, or what you mean.
When they both hit the flagpole,
Mm-hmm.
they're both going to have 3 more kilometers to go, aren't they? Because one's going 9 kilometers per hour, and then one's going 8 kilometers per hour.
Okay. Where are you getting your 3 from?
I subtracted the 8 kilometers minus the 5, and then the 9 kilometers
Oh, okay. Gotcha. Okay. Yeah. So you took this number minus this one?
Yeah.
Yeah. So, and I kind of get where you're going with that.
Yeah.
The one trick is that if you're adding or subtracting numbers, they have to have the same units.
Okay.
So this one has kilometers per hour. This one has kilometers. I'm gonna give you a step in the right direction in just a second. I do want to tell you this is a tough question. I wouldn't put something like this on a quiz tomorrow. I just want to make that really clear. Does that make sense? Okay. That doesn't mean that I don't want you to understand it, because you'll see something like this again in a few days, but not tomorrow on a quiz. Does that make sense? I just don't want anybody to be like, I'm so done, I can't handle this, because I want you to get it. But okay, so runner A is going to run this way. Runner B is going to run this way. They're going to meet somewhere. Their distance might not be the same. Their speed isn't the same. But it's going to take the same amount of time for each of them to travel to the meeting point. Does that make sense? It's going to take the same amount of time for them each to meet. So what if we try and set those times equal? Let me show you what I mean by that. I'm going to say the velocity of A equals the displacement of A divided by the time of A. Does that make sense? That's just velocity is distance over time, or displacement over time. Is that okay? I can say the same thing for B. The velocity for B is the change in position for B over the time for B. Is that okay? Does that seem fair? This time and this time have to be the same. So I think we can set up an equal proportion if we do this in a clever way. This is a tough question, but I like it. I like the thinking that has to happen. Can you get time all by itself here? You look like you just wanted to like shake your fist at me.
No.
Can you tell me, is that true? Are you feeling that way? Like I just want to shake my fist at Miss Carveling?
No.
Or no? You're like, I have my coffee, everything's good. Yeah? Yeah. I think we did this yesterday. How do we get TL by itself? Do you remember? In the numerator?
Multiply by T,
Multiply by T, divide
divide by V.
by V. Is that okay with everybody? A little algebra for our beautiful day. So the time equals delta X for A divided by V for A. That also equals, can I just do this? Tell me if the answer is no. How does that sit okay with people?
Is that one possible?
We need to plug in some, we need to figure something out, right? We want to figure out where they're going to be. Yeah. What are we going to do about this? Any idea? I feel like the algebra is going to be really ugly here. I'm not sure if I'm excited to go through that with you right now.
You should just leave it.
Let's do it.
Well, I want to do it. I'm just trying to figure out if I want to do it today or if I want to do it tomorrow.
Do it today.
So just do it?
Yeah.
Okay, rip off the Band-Aid. Let's do it. Okay. How far is that distance going to be? We need to get that out of there. See, I don't know. So I didn't write this one. You want to just rip it off? You guys are like, let's just do it. I'm not going to.
Hey, why? Why?
Because let me tell you a reason. Can I tell you? I'm struggling because I don't want people to be really, really cranky with me with really ugly algebra. I would rather work it out and then show you the nice, pretty way. Does that make sense? Or no? You want to just do it?
Yeah.
Let's just do. Okay, you guys are so excited. I can't say no. Okay, what are we gonna do? What are we gonna do? We need to find. You want to plug in some numbers? Would that make you feel better? A little like safety blanket. Okay, so the displacement for A, we don't know for sure because we don't know where they're gonna end, do we? Go.
Are we making the kilometers into meters?
I don't think we need to.
No, this is
Because it's all, as long as everything's in kilometers, everything's good.
So
We'd have to convert both of them,
Okay.
or all of them.
So the time is going to be in seconds.
It's going to be in hours,
Okay.
and that'll be okay.
That'll be-
Well, actually, you know what, though? We want to know where, don't we? we want to know what will the distance be. So the times are just going to go away too. Poof. All right, this is where I'm struggling, but I think we can handle it. We want to know where it's going to happen. So we want to know, let's call this final position minus, let's call this 0. Let's call this position -6. Is that okay?
Yeah.
Let's call this +5. Is that okay? +5 and -6 so that we're looking on a number line. Okay. So the purple guy is final minus initial divided by the speed, which was 9. It's 9 to the east, so that's a positive. I feel like are you okay? You're going to stop me if you're unhappy, right? Patients, you're going to stop me if you're unhappy. Ladies, you're going to stop me if you're unhappy, right? Right, Josie? Okay. Even if it feels like it's a dumb question, because dumb questions aren't really dumb questions. Some people just perceive them as dumb, but it's not really true. So I'm gonna make this really clear here. This is a negative. I'm gonna highlight it. That one's negative. And oh, by the way, this one's gonna be a negative because he's moving backwards. Is that okay? Got to include negative signs. I'm not presenting this super well, but you guys are so flexible.
We don't know the final position.
We don't. That's what we're trying to find out.
Big variable.
That's the big variable.
Next to that is just a big variable.
Yes.
Okay.
It is the thing we want. It's the same thing for both of these guys, though, right?
Yeah.
Yeah, that's the nice thing. The initial position for this guy was 5. You guys are so brave. You guys are my bravest physics students I've had all day.
Wait, this one is next to the F minus -5.
No, -5 because this is a +5.
Okay.
Yeah, yeah. I'm glad you caught that. Woo, some algebra for a morning because it's the afternoon now. First algebra for the afternoon too. All right, let's cross multiply, shall we? Are we excited? I love to multiply. Here we go. -8. Oh, you guys are so brave. How we doing? Did I mention this will not be on your quiz tomorrow? Just want to make that clear. This is beautiful stuff, though. It's gonna be so nice. It's gonna come out to me. Poof. What happens next, my algebra friends?
Distributive property.
Distributive property. We love the distributive property, don't we? Yeah. Well, he's like, yeah, I love the distributive property. It's my favorite. I know. -8 XF minus 48, yeah, is equal to 9 XF. Did I miss a minus sign somewhere? No, I didn't. Minus 45. How are we doing? Solve that for XF. You can do it, right? This is a beautiful thing. You guys are digging in. I love this. I'm going to put the XF stuff over here so I can make it positive. And I'm going to move this stuff over here so that I can make it, by itself. So I'm going to add, maybe. Oh, don't do this to me now. Here we go. We're going to add 8XF to both sides. Again, please stop me if you're unhappy. So that's going to be -48 equals 17 XFs minus 45. We're going to add 45 to both sides. Add 45 to both sides. I hope this works out well, because otherwise I'm going to be really sad. It happens, though, sometimes. Whoa, come on, team. So what's that? -3 is equal to 17 XF. Holy cow. -3/17?
Yeah.
Okay. What's -3/17? I don't know. Plug it in. What'd you get? Get out a calculator. I have a calculator. Do you have a calculator?
1764705.
17 what?
Let's do 1.
There! And look, it's the right answer. Yay! It's always exciting when that happens. Sometimes it doesn't work out for me, and then I get sad. Shahad, how you doing? Are you like super excited about algebra or not so much? You're like, this was just a big mess of fun. Come on, team.
So they're going to be on the left of the line.
That's what I was just about to ask. So 0.2, what is this, kilometers?
Yes.
Okay, team. first of all, yuck. But first of all, or second of all, give yourselves a pat on the back for plowing through that, because that's good. Like, he's like, literally, I'm doing it. I gotta give it, make it happen. What does that negative mean?
It's on the number line. If the flagpole is a number line, the zeros are 0, and then everything to the left is a negative.
Yeah, so they're gonna meet right here and they're gonna hang out, right? Other blue. They've also shrunk apparently, but they're gonna be all happy and they're gonna be like, "Yay! We're so happy we're together!" Right? That's where they're gonna meet. 0.2 mile or kilometers from the flagpole to the west. Good show. Did we have to know very much physics to do that? It was way more algebra, wasn't it? Yeah. But you guys can do algebra because you're algebra whizzes, so that's okay. Yeah. I like this problem because I think it's a thinker. I will be honest, if you ever see something like this, well, you'll probably see it on a lab later, but not right now. But the big key here to actually doing this problem was figuring out that the times are equal. Are you with me there? That was the key. Once we did that, then it was all just algebra business. Did you have a question?
No, I was just going to say, but it could be a lot easier.
If it wasn't what? Oh, welcome to physics. Physics is all applied. So I'm not going to say all. My math friends, well, say it's just like convinced now that I like to pick fights with everybody. But like literally I don't. I really like to be friends with everybody. I just like to, identify differences in opinion. Yeah. So I get along with my chemistry people pretty well. My math people too, a lot of them are like, oh, well, physics is just applied math, which makes my heart like break because I don't believe that. But I will tell you that a lot of the applied math problems that you do in math class are physics. Are you with me there? Physics is much more than that. But all of this stuff, like there are like related rates problems that you'll do in like pre-calc, that's all just physics stuff, right? So it's kind of like, it's not just applied math, but we apply a lot of math properties to do physics. So I have to like, defend my physics stuff. How are we doing? Are we okay? Okay. All right. So we're good with homework. Everything's happy. We're gonna look back at our thing. Hey, look at that. Okay. I'm going to ask you, what do you think is going to be on the homework quiz tomorrow? What would you expect to see? Ideas? Thoughts? Go.
The SI unit, kind of like equations that we have to do. Are we going to be allowed to use a chart on that one?
Something like the metric conversion stuff?
Yeah.
Yeah, I would say so. I mean, like I said before, I would expect kind of long-term this year that these 3 yellow ones, okay? Like I would kind of, I don't want to say memorize, but like be familiar with those 3, right? But if you needed to know any of that, I will put it on a quiz for you to like tomorrow. Yeah, because that seems a little unfair to be like, oh, tricked you. You don't know what mega is? Like that's not fair. That's not cool. That would be an unkind choice. I wouldn't do that. Yeah. So SI units, I would say converting, adding, or removing prefixes. Do you know what I mean when I say that? So that would be like going from kilometers to meters, or from centimeters to meters, or from centimeters to kilometers. Like, could you do that kind of problem? Okay. What else do you think might be on this quiz? What else have we done in the last few days? What's that? Absolutely. Like a velocity calculation problem. Or given a velocity and a time, tell me the distance, right? Or given a velocity and a distance, tell me the time, right? So any of those would be fair game. Likely there'll be like 2 of them, one that's just find the velocity and one that's find the time. That would not shock me. Yeah. I haven't written it yet, but that's kind of where my head is going when I write this. Yeah. Those are the big things. Write something in scientific notation, right? So knowing where to move the decimal, all that kind of thing. Yeah. So All right, find V or find T, and then that scientific notation stuff too. The other thing that I would say is on these velocity calculation problems, I'm absolutely going to look for all this stuff, right? So those problems are going to be like 4-pointers. Write down your givens and unknown. Write down the equation. Show me your work. Give me your solution with units. Seem reasonable? Seem doable? Okay, awesome. All right. Any other questions about the quiz? I'm not intending for it to be like a full period. I'm intending for it to be like, I don't know, 15 minutes. Am I going to cut you off? No, because I don't feel like that's fair. If you are a slow test taker, you're slow and methodical, that's fine. I'm a slow test taker also. Does that make sense? But I don't intend for it to be an entire period. Question?
I was just wondering if you knew how many points it's going to be worth.
10?
Okay.
I don't know. I mean, I'm wondering if you guys have realized at this point that points, like the unit points means nothing when it comes to a class because it's all about how many points there are total, right? So, and sometimes I tell my ninth graders this and they kind of explodes their brain. But I could tell you that it's worth 1 million points. But as long as a test is worth 5 million points, then if you know what I mean, it's just a units conversion thing. So yeah, but I'm going to say 10-ish, plus or minus a couple. I don't know. We'll see how we go. All right. Anything else on that? Cool. All right. Let's do a couple ranking tests just to get our brain back in the ranking task realm and business. We did not see this one yesterday, right? Okay, sweet. So just kind of a friendly reminder of ranking tasks, what you're doing, you're going to read, take a look here. I am going to have you process this by yourself first. Do we remember what the word displacement means?
You go from home to school and then back to your home. That's your displacement.
Correct. Yeah. So
You're maybe it's 3 kilometers away, then displacement's 3 kilometers.
right. So displacement literally means change in position. So you might want to write this down just so you don't forget. Change in position. Delta X, you guys have seen delta before, right? Delta, and I kind of alluded to this when we were doing that other problem, is the final minus the initial. Okay? That's what you care about. Given that, each graph below shows a position over a function of time. Rank the magnitude of the displacement during the time interval from 0 to 4 seconds. So you by yourself in your brain, work on this for a moment. Again, you do not have to write down the entire question or anything like that, but write down what you think the order is and maybe a little bit about why. All right, go ahead and have a conversation with your table mates. Come up with an answer, and I give you a whiteboard so that you can write down the answer. Write it really big so then when I ask you to, you can hold it up. You don't need to hold it up quite yet.
So each chapter is one.
But do you know what you just said?
Okay, so I would just. I think it is now, but I'm thinking that.
So these starts
Like if C went back up to 8 after it would be 0. It starts again. No, but D, I think D and E. And then it would be, so it's going to be C is greater than C. C is greater than E. Which is greater than E.
Once you think you've gotten an answer, put it on your whiteboard. Write it really big so that I can see it from where you are. Alex, you guys good back there? You guys are good over here? Stella, you guys are good? Yeah. Happy?
there's no negative displacement.
There's no negative in displacement? We'll talk about it in just a minute. Hold on to the question. Not because I don't want to answer your question, but because I want to have a conversation. Does that make sense? Yeah. I'm not trying to ignore you. You guys are good? Yeah. Have something written down that you feel good about, maybe? I was like, yes, I feel great. All right, show me what you got, teams. Boards up. Let me see. All right. Wow, we got lots of answers. Awesome. Okay, hold them up because I need to look at them. So we've got C greater than B greater than A equals D. A equals D. Are those less thans or greater thans? Which way? Should I be going the other way? That's okay. I just want to make sure I have it written down. Oops. So it's the same as the other one, right? Okay, cool. B equals C greater than A equals D. C greater than B greater than A equals D. C, B, A, D. Okay, cool. All right, so we got 2 answers. Let's take a look at them. I am going to warn you right now because my former students, some of them would get these big egos like, oh yeah, I got it, if everybody else agrees with them. I don't know because I haven't looked at the answer. I haven't looked at the problem because I don't like to do that because I want you to figure out what the right answer is. But I want you to know that you need to process and you need to not turn your brain off just because you agree with somebody else. Does that make sense? Okay. Sometimes the perceived smartest kid in the room gets it wrong. So I just want to let you know that. All right. That all said, I'm just looking at answers here. So we've got rank the magnitude of displacement during the time interval from 0 to 4 seconds. Who would like to defend their answer? I'm not trying to say you're wrong because I haven't looked at them at all carefully. Go, Ben.
So I had C is greater than B greater than E equal to D.
Okay, so you're advocating for this first one?
Yeah. So
Okay.
And C displaces 8 meters. So it goes from 8 to 0.
Okay.
And B, it goes from, I think the graph's going back to 2, it goes from 2 to 6, which would be 4 meters.
Okay.
And then D, it's ends where it starts, and same with A. So that'd be a displacement of 0 meters.
Okay. 0 meters. 0 meters.
Our table agrees with carpooling.
Okay, we have corroboration for that. What do you guys think? This one, I don't know. We were just reading my daughter and I were reading the Make Way for Ducklings book this morning. Do you know that one with like the little ducks that walk across Boston? You know that? So anyway, I'm like thinking of little ducks like walking in this story. So we've got little ducks that are walking 8 meters away and then they come back. So they're coming back to their nest, right? Or something. Okay. So their displacement is 0. Yeah. What's the story in this one? What are the ducks doing? They're just sitting, right? Yeah. They give you a little tracking device on the duck. It's like literally just sitting there. Not very exciting for those 4 seconds. Here, it's walking away in the positive direction. Here it's walking away in the negative direction. That seems reasonable-ish to me. Now, what was your question?
Can there be negative displacement?
Can there be negative displacement?
I don't think there can.
Is it possible for displacement to be negative? Let's take a look at the way it's defined. So we can look at it literally, right? Final position minus initial position. So like in this one, the final position is 6 and the initial position is 6. So 6 minus 6 equals 0, right? In this one, we've got a final position of 6 and an initial position of 2. So that would be 6. Did I do that right?
So
Did I write 6 down before? Or did somebody else tell me 6 before? I might have just written that not thinking. Did you guys say 6 or did I just write that? You can totally blame me. You wrote that down wrong. Should be 4 meters, right? Let's take a look at this one here. So we start out at our final position is 0. Our initial position is 8. So really our displacement for that one is -8. Hold on just a second. Let me finish this thought and then I will absolutely call on you. Yep. And then the final one is 0 minus 0. So again, that would be 0. Okay. So yes, absolutely displacement can be negative. And in fact, displacement has to be negative. Let me just go back to what we were doing before because we need to know positions, right? It's not, again, it's if I'm looking for runner B, I can't just say that runner B is 5 miles from the flag or 5 kilometers from the flag. Because if runner B is 5 kilometers from the flag, how many different places could runner B be? If I'm standing at the flagpole and I know that runner B is 5 kilometers from it, how many different places could she be?
Well, it doesn't say direction, so she could go north, south,
There are an infinite number of places where she could be, right? Yeah, because she whole circle around, right? Absolutely. So, absolutely, our positions have positives and negatives, and so our displacements also can be positive and negative. Yes. Okay. So that's important to know. But
So what I was gonna say is that.
yep.
Even though the displacement is negative.
Yep.
C, it wouldn't be on our C is greater than B.
Mm-hmm.
Wouldn't it still be greater than B? So what I think is just like its absolute value of C would be displacement because then you just have A instead of negative.
Learning happens all the time, right? Read this question very carefully. Focus on the third word of the statement. Rank the, what does it say, Matt? Magnitude. Have we defined the word magnitude? We're going to do it right now. So this is one of those things you might want to write down just to remind yourself. So one thing you want to write down just to remind yourself is absolutely displacement can be negative, right? You've just written this down. Displacement is change in position. Delta X is delta F minus delta I. Does that make sense to everybody, like how I defined that? Okay. And absolutely it can be negative if you're going backwards, right? So if we just look at your displacement between now and you get home, if you call home your 0, then your displacement is going to be negative, right? There's this word called magnitude. Have you heard the word magnitude before? Ever? Maybe not in a physics, but like in anywhere, have you, or is that like a brand new word to you? What's that? Absolutely, yeah. It was a magnitude 4 earthquake. What does that mean? How big it is. Absolutely, yes, yes. Or maybe like if in a literature class or like a creative writing class, right? Like she did not understand the magnitude of this situation. What does that mean? Yeah, how big, right? What does that mean? That it means like how big it is. Magnitude for me means how big it is. Literally, you can take it as the absolute value. or another way to look at it is like the distance from 0. So because of the way this question was worded, I like that we're having this conversation. It's perfect. Because it says rank the magnitude of the displacement during the time interval, this is fine. Okay. If you saw another question later on that said rank the displacement in each of those graphs, what would the right answer to that be? C would be the least, right? If the word magnitude is not in there, then it would be B is greater than A equals D is greater than C. Okay? That word magnitude is very powerful. Means a lot. How are we doing? We okay? Yeah? Cool. Let's do one more. Because we can. What? That's the same pictures. We just did this problem, Miss Carmelite. You didn't. It's new. It's different. Read it carefully. You can erase your boards. I want you to think about this by yourself first. Okay? Rank the average speed of the object during the time interval. Go ahead and have a conversation. Come up with an answer and put it on your board.
Yeah, so the displacement is right. It's the add-ons.
Like 16 years.
But C is negative. C is
Yeah, you can say all the same. That's all. Yep. I love ranking. Yeah. Oh yeah. Like a secret question?
Yeah. So if it's not 0, it's not moving, right?
Correct. Like an A? Yeah. Correct.
So that would be the last one.
It would have the, yeah, it would just have Yes. So speed is displacement over time. So it has it's weird, right? Yeah, which is why we do this. Yeah, like
Speed is too slow, right?
it is if it's constant. But like in D, we're not this is the point of this question. Is to figure out what that means. Yeah. All right, let me see some answers on your boards. Hold them up. Yay for different answers. I love it. All right, so we've got we've got A. Oops, you always write those the other way. I have to start over. It's okay. I just need to like get used to it. So hold on. Okay, so we got D is greater than C equals B is greater than A. We've got D is greater than C is greater than B is greater than A. We've got, D is equal to A is greater than C is greater than B. We've got another one. B is greater than A is equal to D. We're going to have to talk about this, you guys. And D greater than C, greater than B, greater. All right. Oh, you have two plans. They have two plans.
Plan B.
Did that mean you guys didn't agree with each other? Is that what's going on?
We agree that there could be two.
Oh, there are two answers. I see. So B, A, D, C. So you agree with this one and you agree with your own other one. C is greater than B is greater than A equals D. Interesting situation. All right, so we've literally got no time. Like that just happened. Erase your boards. We'll talk about it tomorrow. I'm not going to tell you. We'll talk about it tomorrow.